In this problem, what's going to be discussed is the Heisenberg uncertainty principle. And what that really states is that you cannot know both the momentum and the position precisely. You have to give something up. All right, you cannot know both the momentum as well as the position of a particle simultaneously. All right, so let's read the question. Knowing that an electron is confined within an atom and the distance can be 1 times 10 to the minus 10th of a meter, what is the minimum uncertainty in an electron's velocity? So if we know that that's where the electron has to be positioned, what will be the uncertainty in its velocity? Now, Heisenberg's uncertainty principle is that delta x, an error in position, times delta p sub y, this would be the momentum, oops, not y, I don't know why I chose y, p of x is greater than or equal to h bar upon 2. Now what h bar is equal to h all over 2 pi, all over 2 pi. And if we calculate that value, that's going to be equal to 6.626 times 10 to the negative 34 joule second divided by 2 pi, and that value is equal to, sorry, I got to check my notes, can't even see it, it's so far away, is equal to 1.055 times 10 to the negative 34, joule second is what it is. And so what we can do here is we can calculate the momentum. So the change in momentum, px, is greater than or equal to h bar all over 2 delta x. All right? And so we start plugging these values in. So here we have our h bar, which is 1.055 times 10 to the negative 34 joule second divided by twice delta x. So this becomes 1 times 10 to the minus 10th of a meter. All right? We do this calculation remembering that a joule is going to be a kilogram meter squared per second squared. We do this calculation, we come out with 5.273 times 10 to the negative 25th kilogram meter per second is going to be the momentum. Now realizing that momentum is equal to mass times the change in velocity, we can now solve this for the change in velocity, because that's ultimately what we're looking for. The uncertainty in the velocity is equal to the change in momentum divided by the mass. We know the change in momentum is 5.273 times 10 to the negative 25 kilogram meter per second divided by the mass, which is 9.109 times 10 to the negative 31st of a kilogram. So units of kilogram are cancel, or units of meters per second. And this is going to be equal to 5.79 times 10 to the 5th meter per second. So the error in measuring the velocity of an electron trapped in an atom is going to be, it would be 579,000 meters per second, or 579 kilometers per second. So the error in the velocity is going to be extremely large. It's going to be extremely large. Because, and this only occurs, this Heisenberg uncertainty principle really only applies to subatomic particles or atoms themselves. And you're either talking about the atomic scale or the subatomic scale. For macroscopic objects, Heisenberg's uncertainty principle is not, really doesn't apply all that greatly. All right? If you have any questions about Heisenberg's uncertainty principle or any other topic in this chapter, feel free, please let me know so I can help you and assist you any way I can. Have a good day.